Yes.
I was interested in sidebands on CB radios.
Yes. Yeah. Okay. Let me talk about that just for 1 second. Now this is going to be engineering, but I'm going to make it fun. Okay. So there's the frequency we're transmitting on. Let's make it any number you like. 14.2 megahertz. Say, I'm just making this up. Okay. With AM amplitude modulation, what you do is you make as my voice, the vibrations to my voice, they're all in the 1,000 hertz, audio frequencies, low, like the telephone, like the vibrations 1,000 times 6, like that's like 400 or 500. There's a little kid who wasn't, but those we whistle up to maybe 1,000 or 2, something like that. Everything you hear is from 20 to 20,000 about. Okay. All right. So if I whistle like that, 400 hertz or 500 hertz, there will be a signal right here at 500 hertz above it, and perfect mirror image 500 hertz below it. And if I talk, there'll be a bunch of stuff here, and there'll be exactly the same shape on the other side. And for AM radio, this is a duplication of this. This is the upper sideband, and this is the lower sideband. They're just exact mirror images, and they contain the same information. Now here's the really sad part. If you had like a 1,000-watt transmitter, you have 1,000 watts in your carrier, and all your modulation is only 500, and this side is only 250. So right away, it's not very efficient. Because here's the part that you listen to, and you can tell what it is. You're wasting all that, you're wasting all that. So if you only transmit just the sideband with a voice in it, and not the carrier and not the other one, then you can put the full 1,000 watts right here. And it works much better. It's a lot more punch. Well, do you have a CB radio?
Yeah.
And do you have, is it AM or sideband?
There's no sideband, so I got like 40 channels.
Yeah. Oh. Well, do they allow a sideband on here? Oh, it's just band.
I've got a few friends and they've got a sideband when they don't want me to hear what they're saying.
Well, so you'll find that the sideband radios will go farther than the old AM CB radios. Conditions can be a little worse, and you can still hear it because it's a more effective way to
They
communicate.
just went into it. Well, every time I change a channel on my CB radio, I'm changing the frequency. Right?
Oh yes, absolutely.
Okay. So where did they go on the sideband? Did they go over 40?
No. I'll tell you. We've got little things called filters. The joke is a filter. Like okay, I'm going to put this through a filter here. Okay. And you only hear certain band of frequencies. You don't hear the higher or lower. Okay? You just don't hear it. That's some circuit we make up. So we make up a little circuit that goes like that. All you can hear is the upper sideband. Or you tune the radio and you move it down here. Now all you can hear is the lower sideband. All right? And so now the trouble is that you have to reinsert. It gets this and it.
Okay.
But here's the fun part. If you use the wrong one, it sounds like Donald Duck. Like Charlie, the teacher.
Charlie teacher.
Yeah, exactly. That's what it sounds like, and you don't understand because it's all upside down. My high frequencies come out low. My low. Yeah.
So you're saying that their radio has a filter on it?
Yeah, they got a, it's made for single sideband.
Okay.
And then you pick upper or lower, and then you only transmit all your energy just for the voice. So it's 4. You get a factor of 4 already.
By going through the sideband.
Yeah, you can show all your power. You're only allowed 5 watts, but you put every bit of it right there. Yes.
So,
I'm sorry.
you can go.
Your turn. Go ahead. Yeah, he's going to be polite.
Actually, I was going to ask a question about his. So if it's transmitting at 14.2 megahertz,
Yeah.
and they go to a sideband, and you know how far off of that baseline frequency it is.
Yeah.
If you tune to, say, 500 hertz above
Yeah.
14.2 megahertz, would you be able to hear what they were saying?
Sure.
See, the problem is his radio doesn't have in the built-in filters.
Yeah.
The high-end CBs have regular AM and then upper and lower, and they flip a switch.
Right.
So they transmit and receive on the upper sideband, which his radio does not have.
But if you tune to be
If he had the problem is on a preset
Yeah.
CB radio, the FCC.
You have to
you've got-
clarify.
Yeah.
You can go a little bit.
Yeah, but with preset 40 channels, you're locked into that one frequency, and his radio, of course, is AM only. He gets both sides of it.
Got it.
His filter does both sides, correct?
Yeah.
And then upper, you do transmit upper only and receive upper, and then
Yeah.
lower.
But when he listens to it, there's no carrier.
Right,
inserted.
exactly. That's why he can't hear it. If he had the filter,
Even when it's right side up, it sounds like Charlie Brown. Yes.
So since the quality of transmissions vary with different weather conditions, various different things affect it.
Right, it's just
And
like
you have-
fishing.
And you have so many different options available with ham as far as what you can transmit and receive on. Are there certain ones that work better under certain conditions? Like, it's
Yeah.
this condition
But
now.
Like
so
for
I-
this demonstration tonight, if I had done what I promised, what we'll do is you guys are gonna have another meeting sometime, right? So it'll be a little warmer out too. It'll be nicer, and we'll put an antenna up. Well, we can try. We can try. We can see what we get.
Yeah.
But we just try. But I picked 7 megahertz, or what we call it turns we have 2 names for everything. It's how fast it goes back and forth, the frequency or the wavelength. And we refer to it either as 7 megahertz or 40 meters. That's the wavelength of that. And so that would have been, I think, the best because the antenna is not too big. It's only 60 feet long, or 66 or something like that. And we could have stretched that between the light poles. That's what was my grand plan. But if we went any higher right now at night, because the sunspot cycle is at the very bottom, we wouldn't hear it much of anything.
Could you explain the difference? I think this might be helpful for everybody taking
please.
the test. What's the difference between a frequency and a wavelength, and how do they interact?
Yeah, I'm trying to think of a good analogy to stand up. Okay, you're on a boat, and you're the passenger, and some guy's driving the boat too fast for the conditions, and you're going pow, 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 wave, wave, wave. You're really getting shaken up. And so think about the waves on the water. Okay, like that. And the boat, is coming along and pow, pow, pow. Okay, the length from here to here is one wavelength. From crest to crest, or you could go from here to here, it's the same thing, Or from halfway up as it's going up to halfway up as it's going up. It's all the same thing. That's the wave, okay? Now, if you stood in one place and the waves came by and you weren't running the motor would go up and the motor would go down. Well, that's like frequency. So if you had waves that were close together, you'd be, you can imagine, some little ripple from the wind or something. You could feel it shaking the boat. That'd be a high frequency. But the wavelength would be small. And it turns out, there's a really simple algebra. It turns out that the wavelength, I won't be so cute. The wavelength is equal times the frequency. Frequency times the wavelength equals the velocity of light. Okay? And so this is a fixed, the velocity of light doesn't change. That's a fixed constant. So that means that as one goes up, the other has to go down. Okay? Say this was 10. And if we had 2, if the frequency was 2, whatever they are, the wavelength would be 5. Has to be. But if the frequency were 5, then the wavelength would have to be 2. So as one goes up, okay, so let's just do a couple of examples. 7 megahertz is 40 meters. All right, that's 280. So 3.5 megahertz is 80 meters. That's still 280.